Hello everyone, this is a quick and dirty assigning quantum numbers. So we're looking at quantum numbers, and again, Miss Estridge has done an amazing job on this graph with this chart telling you what each of the letters stand for. N, principal quantum number; L, angular momentum; M, L, magnetic quantum number; and MS is the spin. So we're going to look at these very closely, but she's done a great job telling you where to find it, what each one stands for, and over here it even gives you the numbers, shows the orientation of the orbital around the nucleus, and shows you exactly what I call the number line. I'll refer to this as the number line. And down here, electron spin. Well, there's two ways to look at this. If you look at it from Miss Estridge's point of view, that it's always plus or minus 1/2, yes, those are your choices, and we'll show you what that means in just a few minutes. But if you're looking at assigning a specific element all four quantum numbers, you need to think of it kind of like this, with your possibilities being positive 1/2, negative 1/2, or both positive and negative 1/2. All right, well, hopefully you've paused that or copied it, or you have a copy of it. Let's go ahead and start with looking at an element, or a possible element. So I'm going to look at lithium, if I can find a pen that works well. So here we go with lithium. I'm going to grab my handy dandy periodic table and see that lithium is located on the second level. So my first quantum number is definitely A2. So far, so good. So my second quantum number, if I go back to the chart, I know that lithium is in the first two columns, so it will be an S. So my second quantum number is definitely a 0. So if I stopped right here, if I just paused at this point, I can see that my element is going to be either lithium or beryllium, just from the first two numbers. So again, with there only being one orbital, no suborbitals for S, your third number is also 0. That still didn't help your percentage. You know that it's one of these two. Now, that's all you would probably do in like a regular chem class, but in AP Chem, you're expected to go a little bit further, and if you'd like to learn, here's the last part of it. So I tell students to go ahead and draw what we call the outer orbital notation, and that would be obviously a 2s. And how many electrons do you have to fill for lithium? Just one. So you would stop right there. This is a spin of positive 1/2. So my fourth quantum number would be a positive 1/2. Now, that's true for the northern hemisphere. If you're in the southern hemisphere, where when you flush a toilet it goes to the left instead of the right, you should have drawn this arrow, half arrow going down, spinning to the left instead of the right. Now, let's look at beryllium real quick. Again, right beside of it, so it would be a 2. Again, S orbital. But this time, for beryllium, I'm going to use this one, you would have both a positive 1/2 and a negative 1/2. So for my class, they would put positive and negative 1/2. If you see positive or negative 1/2 in Miss Estridge's, know that it could be either lithium or beryllium. Okay? So let's try another one that's a little more complicated. That was a little too easy. So let's try something like phosphorus. All right. So I find phosphorus on the periodic table. There it is, number 15. And I clearly see that it's on what level? It's on the third level. Okay? So I'm going to put for my first quantum number 3. I think everyone understands that fairly well. Now the next quantum number, the angular momentum number, of course for P would be 1. So my second quantum number is 1. Now if I stopped right here, what would be my possibilities? My possibilities would be any of these 6. All right? If I give you another quantum number, now to get this, you would need to do that number line. Remember the number lines she talked about? And for p's, you have px, py, pz. Always start in the middle with 0, and that'd be -1, +1. See why it's like a number line? So you start counting from p. Clearly it's 1, 2, 3. So you would feel one at a time. And when you feel the last one, you stop. And I have my students to circle it, because that gives you the third quantum number, +1, or just 1, and the last quantum number, +1/2, because it's a half arrow going up. All right. Again, if you had positive and negative here, then it could be either phosphorus or argon. So if you only had 3 quantum numbers, you would know it within those two certainty. Again, 1 in 6 chance. If you don't have the last one, you have the 50-50. And if you have all 4 like this, you would have a 100% chance that it's phosphorus. That's pretty good. Let's look at a harder one. Let's look at Fe. All right, here's the tricky one that gets a lot of students. Because remember, these are not on the 4th level. These are on the 3rd level, the 3D. So that tricks a lot of students. So the first quantum number is not a 4, it is a 3. And that's just you memorizing that the D's right here start with 3. So you got a 3. The D, if you look back at her sheet, is a 2. And then you need to do the number line. But how many suborbitals are there for D? Hopefully you said 5. So here's your 3D. Start off in the middle with 0, -1, -2, +1, +2. See how it's a number line? Now we count to Fe. 1, 2, 3, 4, 5, 6. So I have 6 electrons to place or fill. So let's start left to right. 1, 2, 3, 4, 5. Now you have to double up. 6. You circle that last one so you know your third quantum number is -2. So if you stop there, you know the answer is either going to be the first one, scandium, or Fe. So that may be as far as Miss Estridge wants you to find, or she may just want you to find that it's somewhere in the 3D. So that may be as far as you go in your class. But for my class, we want to go a little bit further, and this time we see what? There's 2 half arrows. So you're going to have positive and -1/2, and that is your 4th quantum number. Okay, what if you're given some quantum numbers, 4 quantum numbers? What could you determine? Well, let's look at one of these. What if you have 1, 0, 0, positive, -1/2? Okay, so first, what is on level 1? Hydrogen or helium? So right now, from the very beginning, you've got a 50-50 shot at it being either hydrogen or helium. What's the second number tell you? The shape of S. Well, you already knew that. Again, third, there's no suborbital. So the last one, if you're only doing 3, all you would know is the first level, hydrogen or helium. In my class, you would see this as and, +1/2 and -1/2. Therefore, your blank would look like this. And that would be the element helium. All right? Well, that was way too easy. Give me another one. So let's try one a little more challenging. 2, 1, -1/2, just +1/2. Okay? Give you a second. You may want to pause it. You may want to try that on your own. Okay, hopefully you've paused it. We go to the second level. We see from the second quantum number that it's a 1. So right now, just from the second quantum number, you know it's one of these elements. You got a 1 in 6 chance of guessing at this point to see that it's one of these 6. Now the -1, if you draw out your number line, 0 in the middle, -1, +1, and you begin numbering. Whoa! I'm already at -1. So I stop right there. I got a half arrow, +1/2, spinning to the right, at -1. So I know this element is, drum roll, boron. Okay, let's try one last one and we'll conclude with this one. So we got 4, 2, 0, and then a positive 1/2. Give you a second. You may want to pause the video at this point. Try it on your own. Okay, hopefully you've had a second to try it. We're looking at 4. Normally we would start here with the number 4. But don't forget, it goes down for the D's. And just by chance, we have a 2 for the second number. So right now, knowing that's a D, we know the answer is somewhere from here to here. We have a 1 in 10 chance of guessing that element. So what do we do for the D's? How many blanks do we draw? You're right, 5. Starting with 0 in the middle, -1, -2, +1, +2, and we just start going until what number? 0. Some people go ahead and circle that first. And when they have a positive 1/2 in that one circle, they stop. 1, 2, 3. Whoa! So you're looking for the third element in the fourth D. So I go to the fourth D, starts here, and I go 1, 2, 3. So my answer was NB. Okay, I hope this helps some, and we'll hopefully give you some more examples at school. Have a great day.